and welcome to a new episode of FooBar. This is 2021 and as you see, new year, new space, well, for a while. In today's episode, we are going to talk about Lambda container image support. This was announced in re:Invent 2020 and I want to show you a little bit of what this means. If you're interested in watching more content about serverless, cloud computing, or software engineer practices in general, subscribe to my channel in the red button below. I'm posting videos, again, regularly as we started the year. Yay! So let's get started! So what container image support for Lambda means? Until re:Invent 2020, we have been uploading our code as zip files. If you have been using serverless since its beginnings like me, this is maybe a launch that doesn't affect you, but maybe it does. A lot of enterprise and organizations and developers are very familiar with containers. Containers are a standard way of wrapping applications and deploying them and packaging them into the cloud and into many different places. So many organizations already have tooling services and systems and CI/CD approaches to deploying container images. So adopting Lambda might have been a little bit hard for them as the zip packaging structure is kind of odd. Basically, only Lambda uses it. For that reason, in re:Invent 2020, a new way of packaging and deploying your Lambda functions was announced, and that's the support for container images. And this allows users of containers to have the same benefits as Lambda users, the scalability, the operational simplicity, the high availability, all these different integrations with multiple AWS services, the event-driven, and many other things by using tools that they're familiar with. So now you can bring your own container images and deploy them as Lambda functions. When you bring your base image, if you are bringing your own, there is support for Alpine and Debian container images. I leave you a lot of reference documents in the description with more information about all the supported images. So when you bring your own base images, you need to implement your version of the Lambda runtime API. If you're using any of the runtime supported by AWS, there's already many clients that have been developed. I also link you the page where you can download the existing Lambda runtime APIs for your particular runtime, but if you're using something that doesn't exist, you need to implement it yourself. And that's kind of the way that the container image will talk to the Lambda platform. Also, there is an existing base image for Amazon Linux, so you can get that one, and that comes with a lot of tooling already implemented. And if you are using a supported runtime like Node, Python, Go, or so on, you can get one of the AWS base images that comes with the Lambda runtime API already developed for you. One thing that is different now than before is now that the code is a container image, and instead of going to S3 as it was before, going as a zip file, you are deploying it to the cloud from your computer or from wherever, you're putting it in S3 as a zip file. Now you're putting the container image into an image repository. In this case, you are going to be using the Amazon Elastic Container Repository, and you need to have a repository in place in order to store your images. So now I explain you a little bit of what this image support means for Lambda, and you might still have a lot of questions. I will show you at the end of the video a demo where we will put all of these things together, so watch until the end. But first, I want to address a question I got asked a lot. What this means for other container services like Fargate. Fargate is a serverless container, so what is the difference now between Lambda and Fargate? Well, there are many differences. They're very different services. You're using Fargate to deploy services or applications, these whole applications that are running all the time. Even though Fargate scales down until 0, kind of, you will still need to launch the whole application when there is a new request, and it's not event-driven. So usually what we do with Fargate is we scale to a minimum basic application that is running and is scaling up as the need for it, as the requests increase, but there is always something running. With Lambda, it's different. Lambda functions are idle. It doesn't matter if they are running a code package in a zip file or in a container image. Lambda doesn't change the way it works due to the way you package your code. It's exactly the same. It's event-driven. The functions are idle when nobody is using them. So that stays true to the core of Lambda. So basically, Fargate and Lambda are still two very different services running containers. So containers are the way that you package your applications, but that doesn't change the way Lambda works. Another question I get asked quite often is, who is the main audience for this announcement? I'm already using serverless for many years. This doesn't impact me. And that might be true. You might not have any interest on running container packages in your Lambda functions, but there is a lot of people that are starting with serverless and they are using Fargate, for example, and they're super happy, but they already have a pipeline of CI/CD, they have tooling for working with containers, they have the expertise of containers, and they don't want to switch to zip files to run their applications. So this is a great announcement for them. Also, this is a great announcement for a group of people that are working with big dependencies. So if you need to work with machine learning or data analytics or things like that, being able to package everything in a container that can be up to 10 gigabytes is really great. Sure, you can have 10 gigabytes of memory when using Lambda, and you can do all kinds of tricks now with the Elastic file system to get a lot of things into your application. But these containers this big allows you to do a lot of things that Lambda might not enable you with a typical zip package, because the zip package has a smaller size. One important thing now, you might be wondering, wow, if Lambda functions are with the zip files are, I think, 250 megas or something like that, and these are like 10 gigas, how the performance works. Well, I will cover that a little bit and how the optimization is done when we do our application, so keep watching. So I explain you a little bit on how Lambda platform optimize your container image in order to be able to get to the same performance as with zip files, because that doesn't change. And lastly, I think another group of people that are getting a lot of benefits with this launch is the people that want very specific runtimes, and there's no support for that in Lambda. Sure, now with Lambda and the zip packages, you can bring your own runtime. There is many ways to do it, but I think now having everything in a container image allows you to do the integration way easier. Just implement this Lambda runtime API in your desired runtime, and voila, you're set to go and run, I don't know, COBOL Lambda functions. So now let's go to the code and check how we can get this done. So we are going to do a simple demo. I want to show you a couple of things, how to do these container images with SAM. I want to show you a little bit of the process of optimization of the Lambda functions after they are deployed. And for that, you need to have, for sure, an AWS account, the latest AWS CLI and SAM libraries, and as well Docker. If you don't want to install all that things, you can do these same steps from Cloud9. So now we can go to the code and we can get started. The first thing we are going to do, as always, is to create a new project. We are going to create a new project, and in there we are going to initialize a SAM application. I'm running SAM init. I'm going to use this helper for doing this, and I am going to select quick start templates and the base image of a container, and then I will select node 12 as my base image. This means that I using one of the base image provided by AWS. So I'm not bringing my own image, but you could do that, not with this tutorial. You will need to do it on your own. If you're interested on knowing how to run your own base image, let me know in the comments box below, and I can get you a demo of that. But for now, I will be using just the base image from Node 12 that AWS provides, and that means that the Lambda runtime API is already created and installed, and everything is in that base image, so I don't need to do it myself. Now I put a name for that app, and then I basically wait for it until it's complete, and then I go and open it in Visual Studio Code. So let's explore a little bit what is inside this project. Let's go first to template YAML. We are familiar there. We defined all our infrastructure for our serverless application. So in there we will see, in this case, one Lambda function that is called hello world function, and we will see a little different thing there. We will see the package type image. This is a new attribute in our functions. Before we didn't have that, but now we have the zip and the image. If we don't put this attribute, it will assume that it's a zip package. If we put it, then we can specify what we want. And also you can notice now we don't have the code URI, we don't have the handler, we don't have any of that. We just have the package image type. The next thing we can see in this function is the definition of the API gateway. And finally, we have this metadata. This is information that some will use for knowing a little bit more about this container image. So you can see there that there is this Docker file and there is this context Docker. The context Docker is where the project is, and then the Docker file is the name of the file that contains the Docker file. Very descriptive. So let's go into that folder and open the Docker file, and there we can see a little bit more information. The first thing we can see is the name of the public from the base image. That is a public container image stored in the public Elastic Container Repository. Then we can see there is the copy, and that will copy the app.js and the package.json to the root of our deployment. So that's good. Then we will run npm install. That's the basic thing because this is a Node application. And then you will see that there is this command that it says app.lambda handler, and that's basically the starting point of our application. As before, we have the handler and we say where is our handler method. Now we have it in here in this command. And if we go to the app.js, we can see that there is this Lambda handler, and this is exactly the same as it was before. We don't need to change it. We could deploy this in a zip file and it will work. So this is a super simple Lambda function returning hello world for the HTTP gateway. So now one thing we can do is build this locally. For that, you need to have Docker started. So if you don't have Docker started, this will not work. So make sure if you want to build this application, you need to have Docker started. Also, this applies for deploying as well. You need to build first. So having Docker installed and running is very important. So do that and then come back, and now you can run some build. Some build will build the application locally, and then we can invoke the function. So now our application is built. You can see that we have a folder .aws SAM on the top, and that's our build application, and we can run now some local invoke and the name of the function, that is hello world function. We are not changing the code here. And then this is just running that function, and we can see that it's using a local image for that. So the next step is to deploy this to the cloud. This it's pretty straightforward. It will be some deploy as always, but the first thing we need to do is to create a container registry in our Elastic Container Registry so we can store our images there. As before, when we didn't have the guided steps, we needed to create an S3 bucket to put our zip files. Now we need to create a container repository for doing that. So this is a step. You can do it from the console, you can do it from the terminal, you can do it from wherever you want. I will do it from the console because I want to show you how this is done. So go to the Elastic Container Registry, and there you just basically do create a repository and you put a name to it. So this will act as your S3 bucket where your zip files were before. Now you have a repository where your container images are stored. We copy the name of that repository. Basically, it's an URL because we will need that when we do the SAM deployed. So we run now SAM deployed, as we are familiar with, SAM deployed -- guided, and then that will help us to deploy our application into the cloud. If this doesn't work, please update your SAM. It changed a lot. So now we put a name to our stack and we pick the right region. The region is important, that is aligned to the region of your repository, so make sure that that's the case. And then you put the image repository that you just copy, and then you just say whatever. I always go by the defaults, and voila, this is deploying. It takes a while, and I will fast forward until it's deployed. But in the meantime, while this is deploying, I want to show you the different states that our Lambda function will go now. I talked you about the optimization part, and we have these 10 gigabyte container images that are possible, and how is that possible? I will not go into the particular details on optimization. Let me know if you're interested in that, and I can maybe bring a guest to talk about the nitty-gritty details on how Lambda platform optimize your containers. But for now, I want to talk about the different stages that your Lambda function will go. Before, when we have zip files, this didn't happen. We basically go from deploying to active. However, now we have a new stage that is called pending. So basically, you have your container image in the Elastic Container Repository, and then you are going to create your function. And while that function is being created, is in a pending state. And during that pending state, the Lambda platform is doing optimizations in that image that you are attaching to the function in order to be able to distribute it around the world in a faster and simple manner. So during the time that the function is pending, in the status pending, you cannot invoke it. Or if you have a already deployed version of this function, it will always invoke the previous version. If you're invoking a version of the Hello World function, now it has two versions, for example, version 1 is active and version 2 is pending, then we'll always go to the active version 1 until version 2 finish deploying and finish the pending status. That means that it's optimized, and now we have an active version 2, so whenever requests come, then they will be served with version 2. So it takes a little while, but it's not that long. The bigger your container image is, the longer it will be in this pending status. So that's something that you have to have in mind, but this only happens during the time of optimization. Then your Lambda function will be as nice, as fast as it always was, no matter how big your container image is. So now our function should be deployed, and let's go back and see what happened. So this deploy as usual, and we have our outputs there ready for us to consume. So I will grab the value for the API gateway and paste it in my Postman, so we can run this function and see how it works. So I pasted in Postman. I have extra spaces, so let's remove them and get the right result. So now I paste it in Postman, and voila, message hello world. Good. So what we're going to do next is going to go to the Lambda, to the AWS console and see what is inside my repository. And if I click on that repository, you will see that now it has an image, and that's the size, 152 megabytes, and it's been published right now. And then if I go to my Lambda, then I can see my Lambda function now is being is deployed. You can see that this function has an image attached. You cannot see the code, and you can see the image URI that is inside that repository that we created, and you can see the version of the image. And if you want to deploy a new version of this image, you can. So that's kind of it. So that was it. All I want to show you. I don't know. I will not leave you the code for this in the description box, because as I said, this is just the tutorial of some init. I just went and explained you what it does, so I don't think you need the code. Just follow the steps and you'll get to the same place, so that should be fine. I will also leave you in the description box some resources that you can check for the Lambda container image support that might be interesting for you, and also leave me in the comment box below what you would like to know more, what kind of demos you would like to see on this topic. For deploying for CI/CD is a different process, so I will show you that in a different video, so give me a thumbs up if that's something you're interested in. And with that, I see you in the next episode of FooBar. Ciao, ciao!